Good morning, guys. So this is an old test question that I'm going to go over. And you can obviously see that this is a Y delta question just by this kind of business right here. But I'm going to solve it using nodal analysis first. And obviously you can kind of tell that you shouldn't use mesh analysis because there's 1, 2, 3, 4, 5 different loops that you would have to use, so you'd end up with a 5 by 5 matrix to solve that. Now obviously there's only one current source, so you could basically lump this all together, and that's what we'll do in the next video. But for this one we're going to use nodal analysis, and the question's asking for I naught, which is down here, and also for the power supplied by this guy. So obviously if you know the voltages, you can find I naught by just dividing by 6K. But what we're going to actually do to make nodal analysis a little easier, first we're going to define the nodes. So we have this top guy. This is all one node. All the wires that are connected right here. This is all a node. And we'll call this guy V1. And then we also have another node right here. So remember, it's where one or more, or two or more resistors or components are connected together, you get a node. So we'll call this guy V2, and then we'll call this last guy V3 right here. And then obviously you have ground at the bottom. So that'll be V3. And I've already drawn my matrix down here. And the other trick I'm going to show you guys is, you've worked some homework problems with this, but nodal analysis actually works a lot easier when you use Siemens, and that is because when you're doing nodal analysis, you're finding currents, and in order to find currents using conductivity, you just multiply the voltage with the conductivity. So I is equal to VC instead of I being equal to V over R. Now it's exactly the same thing, so we're just all going to convert all these resistors into units of Siemens. So just going to basically find a reciprocal. And if you didn't want to do this, you can just basically use the reciprocal of the resistance directly. But I just like to kind of remind myself that we're using the reciprocal here. Alright, so I'm going to write this directly into matrix form. I'm not going to write any equations down. So pay attention and I'll show you how to do this. So basically, if you were to write equations, you would write V1 minus V2 divided by 12 kiloohms. Or if you were using Siemens, you would say V1 minus V2 times 1 over 12 millisiemens. So the K, obviously, if it goes to the top or to the bottom, it becomes milli 0.001 instead of 1,000, since the reciprocal of 1 over 1,000, well, 1,000 the reciprocal is, so K would convert into millis, that's what I'm trying to say. Alright, so since we're going to do that, what we're going to do is we're just going to focus on V1 and see where it's connected. And then we're going to sum up all those conductances. So we have 1 over 6K plus a 1 over 12K connected to V2 there. And then plus another 1 over 12K connected to that V3. And then we also have that 1 over 4K connected to ground. And that's everything connected to V1. And assuming that everything's leaving V1, all of those are going to be positive. Alright? So we can think about if it's leaving V1 and it's entering V2, if we're saying V1 minus V2 divided by 12 kiloohms, we can say V2 is always going to be negative since it's always going to enter. And so V2 in this case is just going to be 1 over 12K. And with that negative sign in the front. Same thing for V3, it's entering into V3, so V3 is also just going to be minus 1 over 12K. Why is it just minus 1 over 12K? Well, that's the only thing connected right here. And the same for V2 right here. So those are the only things connected between V1 and V2, and so we just sum it up that way. Alright, easy peasy. So the next thing we're going to do is do the same thing for V2. So V2 has 3 connections. You can see them right here. And we're going to assume that everything is leaving V2. So if you sum up everything leaving V2, it's going to be 1 over 12. Oops, that's V1's column. It's going to be 1 over 12. Okay, plus 1 over 12k. Plus another 1 over 12k. So it has 3 connections and they're all 12k's. And then if you look at what's connecting to it, meaning what's entering the other nodes that's connected to it, ground we ignore. V3 is just going to be minus 1 over 12k again. And V1 also is going to be minus 1 over 12k. Okay. So V3, the same thing. If you sum up all 3 of them, you're just going to get 3 times 1 over 12k. Oops, kind of messed that one up. And then if you look at what it's connected to, well, it's connected to ground, which is just 0. It's also connected to V2 by minus 1 over 12k. And it's also connected to V1 by a 1 over 12k. So assuming everything's leaving V3, since we're on V3, that's also minus 1 over 12k. And there you have your whole matrix. I never had to write down anything in equations or anything like that. So the other thing we have to deal with is constants. There's only one constant in here. It's only going into V1, nothing else. And as you know, if something's going into it, it is we're going to assume that it's negative, so it would be negative 12 milliamps going into V1. But since we're going to move all our constants to the other side of the equation, this just ends up becoming 12 milliamps. And then for the other two, there was nothing. Okay, so we're going to stick all this in MATLAB or in our calculator real quick. And unfortunately, my calculator died. I need to charge it. I have an Nspire calculator. I recommend getting that one just because it's easy to put matrices in, and it can do complex matrices and stuff like that you're going to need later for AC analysis. But other than that, I will see you in the next video. Okay, so I just plugged this into MATLAB and I ended up getting 24 and 12 and 12. So then if I wanted to find I naught, that's just going to be equal to V1 divided by 6k, which is going to be equal to 4 milliamps. And then if I wanted to find the power supplied, it'll just be the voltage, V1 at the top there, times the current of that supply. We'll call it I supplied. And that's just going to be equal to, let's see, 24 volts times 12 milliamps. So that gives us 288 milliwatts. That's it.